Okay, this is the second day of larger systems, doing systems in variables of 3, x, y, and z. Today we're going to hit the second of the two methods, which is elimination. Just like yesterday in doing substitution, the method is very similar to doing it when you're doing a system of two equations, two variables. It's just there's more work to get into the end. Definitely, again, you want to be organized and highly structured in your setup so you don't lose track of any signs, variables, calculations along the way. So we're just going to run you through a couple examples. We don't need to do too many. A couple of these will do the job. Make sure you got elimination down, and that'll be it for the notes, and then there'll be a quiz to follow. So like doing elimination from the past, we want to get rid of one of our variables using any two of the original three equations. We're going to eliminate the same variable, of course. We want to make sure we do that. So you're going to go in pairs, actually. So you're going to go from the three originals, grab pairs of equations, and then get rid of the same variable. Get that system of 3 down to a system of 2, and then your system of 2 down to 1. And when you're at 1, then we can back substitute our way up through the problem and get the rest of the x, y, z coordinate. So again, a very similar approach to doing two equations, two variables, just more work up front. Okay, let's check out our first system. Now, just so we would all do it the same, I'm just going to pick a variable for you. It's definitely your choice. You can pick any variable to eliminate you want. I think z's actually make sense here because look at the z terms in the three different equations. Having a negative z, then a positive z, that one will be easy. And a negative z and a 2z will also be pretty easy. So think of, again, as what's the easiest variable to pick. It can be any of the three, but definitely going to go with z here. So what I'm going to start by doing is getting my system reorganized. And when I reorganize it in pairs. I'm going to definitely use the negative z in both. The key is you need to have two different pairs of equations. So I've got the first and the second, and then the first and the third. And I've organized them in a way that will make elimination pretty easy. Now what's nice about the first two, the blue and the red, is that it actually is ready to go. So I have plus and minus z, which means I can do the elimination right away. So literally I'm ready to just add those down in columns. In the other pair, the green and the blue, that's not quite ready to go. So we're going to have to take the bottom equation and multiply it through by 2. And then when we do that, combine that with the original green. So there's the bottom equation, the blue equation multiplied through by 2. That creates plus and minus 2z, which will get rid of my z. Now, one thing you guys got to make sure that you do, super important, is that once you get rid of z in the first pair, you got to make sure you get rid of it in the second pair. You don't want to switch variables because that'll actually stop you from going any further in the problem. So now add down in columns, and I've got my x, y, z down to a system of x and y. And then if you remember from doing substitution, at this point we're kind of in the same problem. We want to combine those two into their own system and keep going. So I've taken the red and the green, put them into their own system, and then I'm probably going to go elimination again. Looking at those two equations, I think I would definitely get rid of y. So and pretty easy to do it, set up nice. So I'm going to multiply the x through by 2. Sorry, the red equation through by 2, and then combine it. So there's my original green. Multiply your red through by 2. Create kind of one more system and add. Now, the idea here at this point is that another variable is going to drop out, and I should be getting to the point where I'm now down to a single variable. So the y's would drop. X is negative 3. You know, you've done most of the work at this point. Now it's just going back up through the system and substituting your way back through to get the rest of the variables. Remember, when you go to do your y, you're going to have to go back into one of the two that came from this system. It doesn't really make a difference which one you use. I think I'll do the first one. So we'll go 6 times x, which is going to be 6 times negative 3. Minus 4y is equal to negative 26. So I would add 18 to the other side. And then the last thing to do would be, should be negative there, oops, and then divide through by negative 4. So y is 2. So now I've got my x and my y. Take those and plug those two back in any one of the three original equations. It doesn't really make a difference which one you pick. Let's say I go with the red. So I just got to reorganize a little bit for you guys here quick. There we go. And remember, your final answer should be put together as an ordered triple x, y, z coordinate. And there you go. There's elimination. So like yesterday with substitution, again, the problems definitely have a lot of work organizational-wise. Got to keep yourself really organized. It's very easy to lose track of stuff. Signs, calculations, all that. So the more organized you are, the better. But essentially, excuse me, you start with a system of three. You combine pairs of equations, get rid of the same variable, get you down to a system of two. Get your system of two down to a single variable solve. Then it's back, substitute your way through the problem until you're there. Okay, let's try one more, and then we'll switch to the last problem. There's only going to be three today. Going to keep it kind of short. So this time I decided to get rid of y. Now I could have done z probably just as well, but what I like in this setup is I got that negative y, which means doing the pairs of equations and giving a y will be pretty easy. I'll just have to multiply through by either 3 or 4. So you do have to reorganize the system. So again, we're going to go in pairs. Usually I like to put the equation I'm going to change on the bottom. So when I do the multiplication, it's not so much a mess or keeps things kind of put close together in terms of which ones I'm going to add together. So I'm going to multiply the blue equation through by 3. Keep it kind of simple. Then I may want to make a note to myself, which two am I adding together? Multiply the blue equation here through by 4. And then go ahead and add. Okay, so adding together, my y's are going to drop out. I've got 11x plus 4z is equal to 1. Over here, I've got 17x plus 6z is equal to 1. Now, it's always good to kind of stop along the way and check your work, right? This would be a good spot in the problem to stop because, any errors here ruins the rest of the problem, and of course it means your solution would be off, so I would stop and just check it out. Just make sure I'm on track. So I'm just going back and kind of double check my work quick. So multiplying the blue equation through by 3, that'd be 9, negative 3, 3, and negative 3. Doing the other blue equation, multiply through by 4. So I'd have 12, negative 4, 4, and negative 4. And then make sure that I add them together correctly. So my y's drop out in both cases. I've got 17 and 6 and 1. And 11, y's drop out, 4z and 1. So if you got that far and you're good, then it's just again going the idea of a system of two, put those two together. Now neither one of these is great for doing elimination because of having not a single variable or one variable being a multiple of the other. So there'll be a little bit of work to get this one to eliminate, but it's still not too bad. So what I think I'm going to do is go for the z's because the numbers are a little bit smaller. I'm going to multiply this one by negative 6 and this one by positive 4. What I'm trying to do here is create a plus and minus 24z. So I mean, it wasn't too bad. The numbers are starting to get a little bit big, but multiply through by -6, multiply through by 4, plus and minus 24z. The z's drop out. Now your x's, turn out not to be that bad, actually. Again, I've got my x, so now I can start backing my way up to the problem. So this is where the back substitution comes in. So if I'm picking, I think I'll probably go with the 11 times x plus 4z equals 1. That's -11, so I'm going to add that to the other side. That's going to be 12, so I got a z of 3. Now I've got an x and a z, so go back up and pick any one of your 3 original equations. Again, doesn't really make a difference which one you pick. I'm just grabbing just any one of those 3 will work. So that would be -3 and 3, which would be 0. So that means we're down to -y equals -1, or y is 1. And I got it. So -1, 1, and 3. Final answer. Okay, so that's elimination, right? And again, like substitution, I don't think either one is particularly faster than the other. I think I still like elimination better just because of the organization of it. But it's 2 equations in pairs, 2 different pairs. Get rid of 1 variable and get your system down to 2. Get those 2 combined into another system. Get yourself down to 1, and then start back substituting your way through the problem. Okay, last one here, and then we'll wrap it up. So this one is at checking the coordinate. Is it a solution to a system? We've done this plenty of times. It doesn't make a difference what your system looks like. Pretty simple problem. Basically, you take your original system, and everywhere you see x, y, and z, replace with the given coordinate you're checking. So 2, 1/2, and -3. So I plug those values in, and then what I'm checking is for true statements. Do I get 0, do I get -11, and do I get 1? It has to work in all 3. If it doesn't work in any one of the 3, then you're done. Now, as you go, just checking the numbers out, let's do the first one. We've got 2 plus 1 minus 3, that does equal 0. Check. Here we've got 6 minus 2 minus 15. That's minus 17 plus 6. That does equal -11. Check. We've got -4, -4, and 9. That's -8 plus 9. That does equal 1. Check. Is it a solution to the system? Yes. And that's pretty quick and easy. Just plugging in and checking. Okay. Well, that's going to be it for the notes for elimination. You guys will have a quiz today that has a little bit of solving system of inequalities. So you're going to graph a system in shade. Then you're checking the vertices for max and min, plugging them into an optimizing function. And then one problem from yesterday's material on a system of 3 with substitution. And there's some hints on the quiz to help you get going on a couple of those problems. That should do it.